Question number 2. A ladybug and ant move at constant speeds. The diagrams with tick marks show their positions at different times. Each tick mark represents 1 centimeter. Here are the tick marks: 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, and so on. Here is the movement at 0 seconds, after 2 seconds, after 4 seconds, and after 6 seconds. On the graph, lines U and V also show the positions of the 2 bugs. Here's line U and line V. So this is a graph of their position. You can see the centimeters, distance traveled, on the x-axis, and time on the y-axis. So as time increases, the distance traveled also increases. The question asks, which line shows the ladybug's movement? Okay, well, here's what I want to do first to help me look at this problem. Look at the starting position. In this position, ladybug and ant are both starting out at 0, distance equals 0. And after 2 seconds, ladybug has gone 4 centimeters and ant has gone 6 centimeters. After 4 seconds, ladybug has gone 8 centimeters and ant has gone 12 centimeters. After 6 seconds, ladybug has gone 12 centimeters and ant has gone even further. Now let me count those tick marks and make sure I've got it right. They start at 0 centimeters. And then after 2 seconds, ladybug has traveled 4 centimeters. Ant has traveled 6 centimeters. After 4 seconds, ladybug has traveled 8 centimeters. And ant has traveled 12 centimeters. After 6 seconds, ladybug has also traveled 12 centimeters and ant has traveled, let me count that up, 12, 13, 14, 15, 16, 17, 18 centimeters. Okay, now which line shows the ladybug's movement? Well, ant is faster, ladybug is slower. So let's just take a look here. After, let's say this is 2 seconds. Let's say this is 2, and this is 4 seconds, 6 seconds. You know what? That's not a good scale. Let me try something different. I'll say this is 1 second, and this is 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 6 seconds. Okay, so after 2 seconds, ladybug has traveled 4 centimeters. I'm going to change for red. That'll be a nice color for a ladybug, right? Okay, let me put a red dot on here. After 2 seconds, 4 centimeters. 1, 2, 3, 4. Okay. And then after 4 seconds, ladybug has gone 8 centimeters. 3, so here's 4 seconds. Is this 8 centimeters? Let me count it. Distance traveled: 1, 2, 3, 4, 5, 6, 7, 8. I guess so. I guess it's 8 centimeters right there. Okay, then I'd have to say that line U represents ladybug. And that makes sense. It shows that for the same amount of time right here, line U covers less distance than line V. So line U is the slower line. Which line shows the ladybug's movement? Line U. It's slower. Let's check the next question. Which line shows the ant's movement? Okay, ant is faster. So which line shows a faster movement? That means more distance traveled for the same amount of time. Let me change my color. I'll use this color for ant. At 2 seconds, ant has traveled 6 centimeters. So here's 2 seconds. I'm going to label this 1, 2, 3, 4, 5, 6 centimeters. So here is ant's position after 2 seconds. And after 4 seconds, ant has traveled 12 centimeters. So 6 is there, 7, 8, 9, 10, 11, 12. 12 is here. I'll just label that right there with the scale. And that was 4 seconds. Okay, right here on the line. So now we can see which line is for ant. Ant is moving faster. That's line V. Okay, explain your reasoning. How do you know which line describes which bug's movement? How do you know? Well, if it's covered more distance in the same amount of time, then it's for the faster bug. And if the line shows less distance for the same amount of time, it is for the slower bug. Go ahead and type in your answer here. How do you know which line represents which bug's movement? Question number 5. How long does it take Ladybug to travel 12 centimeters? How long does it take Ladybug to travel 12 centimeters? Let's go back to the tick mark graph. Here is Ladybug at 12 centimeters. You can read how much time it is and enter it in. Question number 5. Question number 6. How about the ant? In other words, how long does it take the ant to travel 12 centimeters? Go back up to the tick mark diagram. Now, we don't see the ant at, here it is. We do see the ant at 12 centimeters. How much time does that take? Put in your answer. Question number 7. Scale the vertical and horizontal axes. It says scale. Please learn the word scale. Oh, I'm trying to write with my pen tablet. It's not easy. I have to go real slow. There, scale. Please learn scale. Scale the vertical and horizontal axes by labeling each grid line with a number. You will need to use the time and distance information shown in the tick mark diagrams. Okay, well, we know that the tick mark diagram goes from 0 centimeters. I'll label that again right about here. 0 centimeters. And it goes all the way up to, let me count it. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Goes up to 18 centimeters. So do we have enough marks here for a 1-to-1 scale? Let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, that will fit. So we have 18 centimeters here. We can fit 18 centimeters here. We don't have to double the scale or anything like that. So let's use the GeoGebra tools here. Click on the ABC tool to label the bottom axes. The bottom axis is the horizontal axis. And it says to type in the scale. Okay, so let's do that here. 1 centimeter. This might take a while, but you need to do it. You're going to get the problem wrong if you don't put on the scale. 3 centimeters, 4 centimeters, 5 centimeters? My 4 centimeter disappeared. Let me fix this. 5 goes here. To move something, click on the arrow. And then you can click it and drag it over. It's not moving for me. Okay, I'll just undo. Go back to the text tool. And I need this here to disappear. There we go. Okay. 4, 5, 6. Now, I don't want to get too crowded in here, so I'm just going to do the even numbers. 8, that's 8 centimeters. 9 centimeters. Oh, I said I was going to do the even. Let me go back. I'll get rid of the 9. There we go. 10 centimeters. 12 centimeters. 14 centimeters. 16 centimeters. And 18 centimeters. I think some of these are kind of hard to see, so I'm going to try to move them around a little. Go to the Move tool, click on it. Yeah, it's still not moving. I'm not sure why. My arrows won't move it. Okay, my computer might be lagging, so it's not moving for me. That's fine. Let's go ahead and scale the vertical axis elapsed time. Now we see the time goes 0, 2, 4, 6. So we need at least 6 seconds on this scale. Let's go ahead and label this 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. See if you can make yours just a little neater than mine. Okay, the question 7 was scale the vertical and horizontal axes by labeling each grid line with a number. We did it. You will need to use the time and distance information shown in the tick mark diagrams. Yes, we did that. Let me just review how I did that. I looked at the information for seconds. We went from 0 to 6 seconds. So I made sure that my vertical axis goes from 0 all the way up to 6 seconds. And the distance, remember I counted at the very beginning? It started at 0 centimeters, and the maximum distance shown is 18 centimeters. So I made sure that my horizontal axis goes from 0 centimeters all the way up to 18 centimeters. Okay, question number 8 asks you, how fast is each bug traveling? How fast? They want to know the speed, centimeters per second. How fast is a speed? So you need distance per time unit. So in this case, it's centimeters per second. The problem told us that they were traveling at constant speeds. Okay, let's see how far Ladybug goes. After 2 seconds, Ladybug travels 4 centimeters. So let me write that down here. Ladybug travels 4 centimeters in 2 seconds. Her speed is, let's do the math. You need pencil and paper to do the math. Her speed is 4 centimeters divided by 2 seconds. Okay, do the math. What is her speed? You got it. Her speed is 2 centimeters per second. Go ahead and type in your answer. And then what about ant? How fast is ant traveling? Let me get a different color for ant. Look at the tick mark diagram. Ant travels in 2 seconds. Can you see where ant is? I'll draw it for you. In 2 seconds, ant has gone 1, 2, 3, 4, 5, 6 centimeters. So let's write that down. Ant travels 6 centimeters in 2 seconds. So ant's speed equals do the math. 6 centimeters divided by 2 seconds. And that equals 3 centimeters per second. My pen is very messy, so I hope you're listening carefully, not just trying to read this and copy me. If you're just reading and copying me, you're going to make a lot of mistakes. You need to understand what I'm teaching. It might be best to take notes on your paper before you answer the problems for yourself. Okay, go ahead and type in your answer here. Label each bug and their speed. Don't forget to tell units in your answer. Units. The units for speed are distance over time. In this case, centimeters per second. Okay, type in your answer, please. Next question. Question number 9. Will there ever be a time when the ant is twice as far away from the start as the ladybug? Explain your reasoning. Okay, well, here's how I'm going to solve this. Now, ant is going faster. Is there a time when ant will be twice as far away? Well, let's see. For every second, ant goes 3 centimeters and ladybug goes 2 centimeters. So I'm going to just make a little table here. Hold on, this pen is so messy. Why don't I try the text tool instead? Okay, so here's my little table. We're going to have time, and then we're going to have ant's distance, and we're going to have ladybug's distance from the starting point. Let me draw some lines here. Okay, we're going to make a table and just look at where their distance will be from the starting point. And then try to see, is there ever a time when ant is twice as far from 0 as ladybug? Okay, so how about at time equals, the graph finished at 6 seconds, right? Yeah, went all the way to 6. And you can see ladybug is not half as far as ant. What we're looking for is a time when ladybug is only half as far as ant. Okay, so at 6 seconds, let's review that data. Remember, ant travels 3 centimeters per second. Ladybug travels 2 centimeters per second. I need to put my units here, but it's hard to write. There we go. So at the time 6 seconds, ant has gone 18 centimeters. Ladybug has gone 12 centimeters. Is 12 half of 18? Let's take a ratio. Is 12 half of 18? No, it isn't. Let's reduce this fraction. See, 12 divided by 6 is 2, and 18 divided by 6 is 3. So that is not equal to 1/2. It is equal to 2/3. We want to find a time when ant is twice as far as ladybug. But here, ant is only how should I say, ladybug is 2/3 as far as ant. Ant is 1/3 farther. Okay, well, what happens after, I don't know, let's say 10 seconds? Now, after 10 seconds, ant has traveled 30 centimeters, because 10 times 3 is 30. And after 10 seconds, ladybug has traveled 20 centimeters. 10 times 2 is 20. So how about now? Is ladybug half as far as ant? Let me just draw a little diagram. So after 10 seconds, ant has traveled 30 centimeters and ladybug has traveled 20 centimeters. Is ladybug half as far as ant? Half as far would be 15 centimeters. So no, ladybug is more than half as far as ant. And you can do a ratio here to see. Ladybug has traveled 20 centimeters and ant has traveled 30. That is not equal to half. It is again equal to 2/3. Okay, let's do another number here. Let's say they keep going, because eventually ant's going to go much further than ladybug, right? Okay, let's say they've been going for 100 seconds. And now ant has traveled 300 centimeters. Ladybug has traveled 200 centimeters. How about now? Now is ant twice as far away as ladybug? No. Ant is not twice as far as ladybug. Let me flip my ratio over. Look at it this way. Ant has traveled 300 centimeters. Ladybug has traveled 200 centimeters. That is equal to 1.5. Not twice as far, but only 1.5 times farther. There will not be a time when ant is twice as far as ladybug. Ant will always be 1.5 times farther than ladybug. No matter how much time goes by, ant will always be 1.5 times farther than ladybug. Ladybug will always be 2/3 as far as ant. Let me help you explain this answer because it's a little difficult to think about, isn't it? So let's just type this in together. I'll help you. Since ant travels at 3 centimeters per second and ladybug travels at 2 centimeters per second, ant will always be 1.5 times as far as ladybug. And ladybug will always be 2/3 as far as ant. You can look at the ratios of their speeds to see. Okay, since ant travels at 3 centimeters per second and ladybug travels at 2 centimeters per second, ladybug will always be 2/3 as far as ant. Ant will always be 1.5 times farther than ladybug. So never will ant be twice as far away as ladybug. Only maximum of 1.5 times as far away. Okay, good job, guys. Let's keep going. Question number 10 asks, question 10 says, refer to the tick mark diagrams and graph when needed. Imagine a bug that is moving twice as fast as the ladybug. On each tick mark diagram, mark the position of this bug. Okay, I think I will pause the video and start a new video to help you with this one so that this video doesn't get too long.